Now, of course, any point in time you got any questions you should ask, please ask. Especially when you have certain parts that you don't understand what I'm talking about. Okay, so let's start with the first one. The whole question looks a bit like this. A bit quite long, right? This whole thing. So there's a part A, there's a part B. Part A is the kind of question with no numbers, so that's kind of scary. Part B is the kind with planes and so on. So I suppose you've tried. So let's go through them. Okay. So let's talk about the first question, all right? Point ABC has got the position vector ABC. That's pretty easy to understand what it means, right? So given that non-zero values called lambda and mu such that this is this, show that they are collinear, all right? So the job is pretty simple. You are supposed to show that they are collinear. How do you show something is collinear? All right, so you must have a very clear idea what you want to do first, okay? What you want to do is, or rather what you want to show, is that your AB is equal to K times AC, where K is a constant, right? Or AB is equal to K times BC, okay? Or AC is, you get the point? So the whole idea is you just make sure that you have a common point. Doesn't matter who is the common point. It could be AC, BC, it could be AB with BC, it could be AC, AB with AC. It doesn't matter which version, as long as they can be related like that. They are already collinear. Understand? There are only three possibilities. Let me might as well just write down the last one in case you have it. So there's AC equal to K of BC. All right. So then the common point is C. So as long as you can choose, prove either one of these, you are in business. You've already shown. All right. It's a 2-mark question, so can't be that bad, right? So let's try. So bear in mind, this is my main thing that I want to do, right? Which is what I want to show. Okay. And of course, along the way, you were given all these hints, and I don't know, hints, or maybe what to call it, probably the tools you have to help you get all this done. So let's try. Maybe I will just pick one. Maybe the first one, AB equals to KAC. So that's my target. So what is AB? Well, you better know that AB is OB minus OA, right? So that's B minus A. Pretty easy to understand. AC is of course OC minus OA. So that's A minus C minus A. How does this look like it's related to this? You get me? Not that obvious. Okay? But we have something to help us, which is right here. So we now know that lambda A, okay, since lambda A plus mu B plus C is equal to 0. This tells me something about my A. Okay? If you like, you can call it minus A or whichever way you like. So it doesn't matter. So lambda A is, maybe I should just bring it over. Minus lambda A is mu B plus C. Make sense? So I just bring one over. So I got this. And of course, if you look at this and you go like, hold on, maybe what I can do is I can put in, I can make my C the subject. I think that's much easier. Hold on. Then maybe I have 2C, A, C, B, C. Okay, so I don't use this one. I think the C is easier on second thoughts, right? So AC, I use BC instead. So C minus A, okay? Because there's a very nice clean C right here. So C is equal to minus A, lambda A minus mu B. Yep, okay, so C is a good choice. All right, what I mean is you have ready C. So what you want to do is to put all the C's back, and then you realize that your BC can be written as minus lambda A minus B minus A, where your AC is actually minus lambda A minus mu B minus A. No, sorry, this is B. It can't be both of them look the same, right? Okay, here we go. Okay, so this is C minus B, this is C minus A. Okay, and this is how C looks like. Okay, so my lambda is this. This is from given. Okay, so given this and given that. So if you put a lambda inside here, all right, so that's what we're going to do, which is ending up with C equals to minus mu minus 1 minus mu B. A, and then minus mu B. Okay, good. And this is what is going to help us. So C is equal to mu A plus A minus mu B. So if you shift things around, you're going to get C minus A is equal to mu A minus mu B, which is C minus A is equal to mu of A minus B. Then this is actually your AC is equal to mu BC, BA. Then you should. Okay? So we end up with this version, right? AB with AC. Yep. Okay? Okay, so it's really substituting here and there. You can go a bit longer, which was what that will happen if I continue doing that. But if you use the right thing at the right place, which is this is the part that is given, this is the part that's given, and you actually just substitute into this, you will arrive at where you want quite quickly. All right, but of course you must have a direction, and the direction is that one of these will work. It's just that you cannot really forecast which one. Like for example, I actually started off by thinking that I'm going to try to use my BCAC. It turns out this is totally not what's happening in the end. Okay, so but at least we have the idea, we saw the idea, and then but the whole idea is that we really just substitute from what is given to us. Okay, so what's given to us is here, put it back in, and then we get eventual answer. Cool? All right, so this is the kind of question which I like to call no numbers, all right, because when there's no numbers, it can feel a little bit more challenging. Okay, so let's take a look at part 2 quickly. Part 2 says, show that the point lies on AB produce. Okay, it's the same question, but I don't think we need the first part of the answer, so let me find some space. So for part 2, the truth is what you want to do is, AB produce means this, right? BA produce, and then you have a B, have a P here. So the idea is that they are collinear. So again, your job is to show that they are collinear, all right? And therefore, you do want to show something like AP is equal to K of PB or BP or something, okay? So maybe BP, all right? So at least it's a little bit consistent there. Okay, so this is what you want to show. Again, you want to be clear about what you want to show. Show that they're collinear. So AP is P minus A, and K, of course, we don't know what's K. But then we do know that this is P minus B. All right, we're supposed to show that this is true. So P is that number over there. So we put in P. Agree? And then we get this. So we clear things up a bit. We're going to get 3A minus 3B is equal to K times, what is this? 4A minus 4B. All right, now if you're clear enough, you already can sense that they are collinear. All right, because if you factorize out the 3, they actually have the same direction, which is A minus B. So the K turns out to be a number they can actually work out, right? The truth is we actually don't need the K because the K is the 3 over 4 or the 4 over 3, depending on how you see things, okay? So if you investigate a bit, you realize that, hey, this is like quite clear, right? They are collinear. I mean, this fits in because after all, these are just constants. But because you need to show, then you have to explain that they're constant. And then you know what's the worst thing? You need to find the ratio eventually. So somehow you need to solve the K. And if you present it this way, it may not be obvious what K is because it seems like you're finding an unknown that you don't know what to resolve. So much easier if you just present it this way. All right, so you actually have it this your AP. Eventually, AP is this, right? And then you found your BP, which eventually your BP is that. Okay, so in a way, you want your PA to PB, which is this. Alright, so then you can find the ratio, which is 3:4. Okay? Can? Alright, so you must know what you are trying to do, which is the showing that they are collinear. So for both part of the questions are both showing collinear, that's all. Alright? So that's the focus of this question, showing collinear. Any questions, quick? Anyone did it differently? I think it's roughly there, alright? But you must know what you are trying to drive at. Okay, this one comes with planes and is a lot more work to do. So it's a lot more busy because we have to do quite many things at the same time. So let's talk about this quickly. Now, there are two planes, typical. Alright, information given, I have two planes. Point A lies on pi 2. Alright, show that the perpendicular distance from A to pi 1 is this. It's again a show question, but basically they just ask you to find the perpendicular distance, that's all. Now, what I find this question is that you should not be so hung up over the fact that this lies on pi 2, because I think that's a useless information. Okay, useless piece of information for this, for what we are trying to do. What you want to do instead is to try to imagine what exactly is happening. Now, you see, you have a plane called pi 1, and you have a point called A, right? Which is 1, 7, minus 10. So write that down. And you are trying to find this distance, which is what is called what is known as the perpendicular distance, or the shortest distance, if you like. This is it. Okay, so A is on pi 2. Actually, it doesn't matter. You just know that I need to do this. Now, there are a couple of ways to do this. Let me run through the concept quickly, but it's only 2 marks, so we use a shorter way, which is the projection way. Okay. So there are two ways to do this. One way is pretty obvious, and that is you go and find the full perpendicular, all right, which is, you can call it point F. Once you found the full perpendicular, you can find the AF vector, and once you found the AF vector, you multiply it, you get the length. That sounds like a lot of things to do, but it will work, okay? So, but for 2 marks, I'm not a big fan of doing so many things, so I will use the projection way, which is the second method. Right, choose one point on pi 1. Let's call this point P. Wait, hold on. Is there a P in this question? Okay, I know just use Q. I don't think I see Q. Right? So choose a point that's on pi 1, and I call it Q. And then, once I got Q, I can find the vector AQ. And once I got the vector AQ or QA, I can project it onto the normal, and I get the length. It's called the length of projection. So this second method will be a bit shorter, okay, because of the fact that, well, we just find exactly what we want. Okay, so let's try to do that. So first thing first, you need to have the point called Q. Point Q lies on pi 1, right? What is point Q? Now, the question never provides us, but the idea is when you have the equation of the plane, you have the ability to find any point you want. Okay? So, of course, you can let point Q, now I got to erase the whole thing. Okay, so let OQ equal to 1300. Now, I hope you understand how I get the 1300. It can be any other combinations, okay? Just make sure you get the 13 on the right side, and that'll be all right, okay? So there you go. This is OA minus OQ minus 12, 7, minus 10. Okay, cool. All right, so that's the AQ. Now, once you get the AQ, you can do the projection, which is what we're going to try to do here. So the required distance, or what we call the perpendicular distance, is your AQ dot n cap, and the n cap is the 133. So 133 is 9 plus 9 plus 1, right? So 3 square, so it's 19 plus 1. Sorry, pi 1. See, I copied the wrong equation. Sorry, my bad. This is very unforgivable kind of mistake, right? Because you copy the wrong equation at the wrong place. Okay, so it's important to keep track of the information. Sometimes it's a bit too much. Okay, so the unit vector of the normal, correct? So that's 16 plus 4 plus 1, so that's 21. Okay, so no need calculator for that. And then we should get the distance that we are looking for. Now we better use a calculator, right? So we have minus 12 plus 14 plus 40, and then we get 42. So this is 42 over root 21. So if you rationalize, you're going to get 2 root 21. Okay? So part 1 is only 2 marks. And now if you look at the workings that you have to present, well, it's rightly so 2 marks. Okay? Now, any questions or not? Usually when people, when I go through this kind of things, the usual question is, people get a bit confused by the projection thing. Okay? Anyone got this issue? Because if you do, I can revise a bit with you the triangle thing. Okay? Because projection does have the triangle, right? You have a perpendicular side and the adjacent side. Are you all familiar? Okay, because in class we talked about it before, but revision, that's part of it. Okay, so not just want to solve the question, but at the same time I want to know what your problem is. Alright, now solving the question is like that. I can just show you all the workings, but if you don't understand, it doesn't help. So try to understand completely what is happening. Okay, so just ask in case you have any issues. Alright, so that's the required distance which is using projection. So if you understand that, that's awesome because that's the best way to do it for 2 marks. Alright, let's move along. Hence, or otherwise, find OB, where B is the image of A when reflected along the plane pi 1. Now, this diagram is kind of useful, quite durable, we can keep using it. Except that this point I probably put somewhere here, because we reflect down the point B now. So, let me use something a little bit more striking, red. Okay, so this is the point B. Okay, now what it is a reflection along the plane, which is the plane is now something like a mirror, if you like, or glass, so it's being reflected over to the other side. So you want to find the point called B. That's your job. Now, how do you do that? The truth is, there are a couple of ways you can do this, okay? But the easiest in the sense that it's easiest to understand, and therefore easiest for you to replicate in exam, would be to go and try to find this point called F. And once you found the point F, then you understand that AF is equal to FB. And then you can find B, which is quite alright. Okay, now the question says hence, which also suspect that well, we actually can use this answer. Now, I don't quite like that method because you end up have to figure out a lot of things like whether the normal is pointing up or down, and then you have to find because once we know this distance, we actually know the AB distance. The problem with knowing AB distance, but we don't know whether the vector or the direction 1, 2, minus 4, is it AB or BA? Then we have another set of problems. So that one requires more investigation work. Then I realized that it's not that shortcut anyway. So might as well we do something that's easily replicated, which is to find the full perpendicular. So I'm going to do the otherwise way, which is the more common way. Alright? So the hence way, I'm not a big fan of it because you end up having to do a lot more figuring of things out, then I don't think it's worth the trouble. Okay, so let's try to find the point F, and then we are going to use F to find point B. Okay, so how we do that will be, well, relatively easy because point F is the intersection between the line and the plane. So the equation of the line AB, alright, will be R equals to the point which is pretty obvious called point A. Have I used lambda in this question? Okay, so no. Alright, so we use lambda. So this is the equation of the line AB, alright? And I'm going to intersect with the plane pi 1, which is this. So I'm going to literally substitute this inside here and solve for my lambda. Okay? So, and once I got my lambda, I got my point F. So that's the strategy. That's the idea that you should have in your head. So that's my R, which is the same line. I'm going to put this inside there. So it's going to look a bit like this. Okay, something like that. And you can solve a lambda from here. Okay, so solving lambda becomes 1 plus lambda plus 14 plus 4 lambda plus 40 plus 16 lambda equals 13. I have no idea what lambda is, so let's try to work it out. Okay, so we are going to have, what is the number on the right side? So I have 13 minus 1 minus 14 and minus 40. Okay, very troublesome number. So 42. Okay, what's my coefficient of lambda? 1, 4, that's 5. 5, that's 21. Okay. So lambda equals to minus 2. So once I got my lambda equal to minus 2, I got my OF. because OF will be simply when lambda equal to minus 2, right? So 1 minus 2 is minus 1, and 7 minus 4, so that's 3, minus become plus, so minus 10 plus 8, that's minus 2. So somehow we figure out our OF. So OF is not the answer because OF is the midpoint. Okay, OF is the midpoint. So I need the OF to help me find my OB, right? So according to the diagram right there, OF is going to be mighty useful. So, all right. If you cannot recall how the diagram looks, I'm sorry about this scrolling up and down, but no choice. It's a very long question. All right. So we understand that AF is equal to FB. Now, this is the part that I again want to nag at you, and again I want to remind you that there are other ways to do this. Like some teachers, some students will do a midpoint theorem to find OB. Nothing wrong with that. It's just that I don't think you need to use something so advanced to do something so simple, right? Because it could be simply like this: AF is equal to FB. That's it. Okay, and the truth is you actually know all of it except B, right? So. Great, where's my A? Now I forgot what my A looked like. Okay, A is 1, 7, minus 10. Okay, so this is OF. 1, 7, minus 10. OB. So, we should be able to figure out OB. It's just adding, subtracting, so let's try without calculator. So I have minus 1, which is minus 2, plus minus 1, so that's minus 3. I hope that's correct though. Then I have 3 minus 7, which is minus 4, minus 4 plus 3, so that's minus 1. And then I have 10 minus 2, which is 8, 8 minus 2 is 6. Okay, so that's my OB. I seriously don't know whether this is correct. Let me check answer first, okay? Where's my answer key? Minus 3, minus 1, 6. Yep, that's the OB. Okay, now this is pretty standard kind of things to do, all right? So make sure you really understand how to do it because you're supposed to try your best to replicate it, all right? Reflection, that means you need somehow to figure out the midpoint. They can use this to help you find the reflected point, all right? So the picture does help you to understand what you need to do, what you need to find. Yes?
For the R,
R. What do you mean R can be anything? One more time. R is actually the line, the line AB.
So because the formula is R dot N, right?
R dot N, okay, which is here, right?
Because the
Yeah.
the R is not perpendicular to the plane.
Okay, not true. It's not as long as it's perpendicular. You must use the right line. You see, what we are trying to do is we are trying to find intersection between this line and the plane. So it's really this line, not any line. Because you are asking, as long as it's perpendicular, no. Because if it's perpendicular, you may end up getting this point. You see? So you want to be more specific. You are trying to find the intersection between the line AB and the plane. So which is why the equation of this is AB. This is the equation of AB. Alright, so AB, of course, A must be involved, and then the direction. Direction is the normal, so you can just use the direction which is perpendicular direction. So then this combined together gives me the R. Okay, and when you're trying to solve intersection, you're trying to solve simultaneous equation. Simultaneous equation means you have two equations, right? So this is the equation of the line, this is the equation of the plane. So simultaneously, there's only one way out, and that's substitution. So you substitute in, then that's how you get this. Okay?
That's for the distance one?
Yes. This formula.
Yeah, the last one.
And this one you're not sure. It's a different thing. So if you are not sure about this, what's going on, that means you are not sure about the right angle triangle. Now in the notes, that's why I forgot to print one for myself. In the notes, I can't remember which page, but there's one. I do remember that I always put that in because that's one of the big things that you need to be very clear with. So let me show you that picture. All right, at least you know which picture I'm talking about. Oh my goodness, I'm going to scroll this forever. Okay, yeah, this is the one. Okay, so this right angle triangle is very important to do many things. Okay, one of the many things is that it allows you to find two particular length that you want to talk about. All right. So the typical setup is this: you got a vector A, which is always the hypotenuse side, and then you have a vector B, which is I like to call it the base. So the hypotenuse side and the base. So the angle is called theta. Okay. Now the length of projection of A onto B, which refers to this. You want to think of it like shadow. The shadow of A casting onto B. This formula is given by A dot B cap. Alright, let me tell you the messy things first. Okay, the next one is, of course, then this length is called the opposite length. This length can be found using A cross B cap mod. So the purpose of learning the dot product and the cross product, one of the purposes is to find this length and that length. Okay, now you have to remember, but the problem is sometimes you must understand that the picture may not look like this all the time. For example, sometimes you may have a setup like this, right? So you have a vector called vector A, and then you have a normal, and then the question says find the length of projection of the A onto the plane. So if you are interested in the length of projection onto the plane, you are interested in this length. But what many people memorize is this: length of projection means A dot B cap. So when they see this, they thought that, oh, I know what, I'm going to find this length. So they're going to take A dot N cap. This will be wrong. Because when you do A dot N cap, you are trying to find this length. Okay? So it can get confusing because the triangle may not look like this. Sometimes it's being rotated and flipped and all. That's why it looks like this now. So instead, to find this so-called length of projection of this vector onto the plane, this length should be A cross N cap. Now, and then you say, oh, this is awfully confusing, which I totally agree. Right? Because, you see, like here, length projection called A dot B cap, but then when I use it here, it's not A dot B cap, it's A cross B cap. It's like, what the? Okay? And I totally understand it can be confusing. So, which is why you want to go a little bit deeper and understand that dot product is something to do with cosine. And you better memorize. Cross product is something to do with sine. This helps because, you see, when you are trying to find this length, and if you look at this right angle triangle, the hypotenuse side is the side that you must have. The angle will be the angle that you make with the other vector, right? Like, come on, it cannot be this angle because this angle, you totally don't have this vector at all. So, when you have these two vector, or one direction, one vector, or whatever you want to call it, but basically these two vector form an angle, and you are interested in the length here. Now, this is the adjacent side. The hypotenuse side must be given, but the adjacent side will be the cosine one. So the cosine is the dot product. Okay? And the opposite side, which is here, is the one with the sine, and then it must be the cross product. So that's one way it can help you to see this. Because if you understand this sine cosine thing, then you understand that over here, there isn't many excuses that you can actually do this. Alright? Why? Let's think about it. You see, you have the vector A, you have the normal, so the angle we're talking about is here, right? I mean, they must form an angle. The side that you're trying to find is the opposite side. So it can't be A dot B cap. It's sine. It's the A cross B cap. So that helps you reinforce this right angle triangle thing. Okay? So it can be confusing because sometimes you use the wrong thing for the wrong thing, and worse is that the words all sound the same. It's called length of projection. You understand, right? Okay? So once you understand this, then what we were doing here makes a bit more sense. Because remember, I'm trying to find this length. And if I can find QA, which is the vector QA, now QA becomes the hypotenuse side. Can you see that? And I'm going to cast a shadow onto the normal. And I'm trying to figure out this length of this shadow. That's the cosine because that's the adjacent side. That's why A dot B cap. In this case, N cap. Clearer? So that right angle triangle diagram is very important, you know. You have to somehow internalize it because you're going to use it a lot of times to find whatever length you're trying to find. Okay, clearer? Alright. Any other questions? Yes, hi. For the hands one, okay, that one is a bit harder because you need to figure out the angle, whether it's a cube or not, and then therefore the direction. But you want to talk about that one probably later, lah. Okay, if you've got chance. Okay, I don't like it because you have to investigate more things like A, B. Is it this or is it B, A? Then you get what I mean? Open a big bag of worms. Half the time you get it right, half the time you get it wrong. Because half the time is plus, half the time is negative, alright? Then it's like, what? Okay? So, not fun. I honestly don't think that that's... I would say that this red color approach is more useful. Why? For a few reasons. Number one is that you obviously need to know how to find proof of perpendicular anyway. So you're not learning extra things because you are doing things that you're already supposed to know, which is find proof of perpendicular. And then you are just trying to use the proof of perpendicular to help you find the projected, the reflected point. You follow? So I find this approach will be more useful than to use the length. Okay, using length is I don't like, but there's some school teachers like to do it. Okay, but then when they do it, they don't explain clearly how they figure things out. They just tell you, oh, it has to. Then it's like you ask yourself a question that you cannot answer. All right, and that one will be another thing. Okay. Let's move along quickly, alright? Otherwise, one question will take a bit too long, right? Write down the Cartesian equation of both this and this, and find the vector equation. This is easy. I would say this is easy. I forgot to load my GC. Let me get my GC up. Alright, but first of all, let's convert to Cartesian equation first. My equation looks a bit like this. I tell you what, I need more space. This is making me giddy, you know, like moving up, down, later I vomit, seasick. Okay. So, Cartesian equation of this I think is easy, so let's just get it done quickly as possible. So that's x plus 2y minus 4z equals to 13, that's pi 1. For pi 2, I hope I don't copy the wrong equation again, we get this equals to minus 8. Agree? So that's it, done. Write down the Cartesian equation. Write down means no working. Alright. Next is find the vector equation. When they ask for vector equation, it's not Cartesian, so it's the one with the direction and point thing. Alright, intersection between two planes. So when you have intersection between two planes, we use GC. Okay? Sorry, my GC looks very busy, but anyway. You just use GC. I'm quite sure you know how to do this, so I'm just going to quickly show and get past it. How come my GC has so many apps? Anyway, this is the one called simultaneous equation solver. Alright, we have two equations, but three unknowns. You better know it. And punch in the unknowns, okay? So it's 1, 2, negative 4, 13, and 1, 3, 3, minus 8. Okay, cool. Alright, if I press enter, okay, cool. Alright, solve it, you get this. The challenge is not in using the GC. The challenge is understanding what the GC tells you, right? So I'm quite sure you learned this before, again, a revision, so we try to cover a bit, but I don't want to go too deep because it may be boring, because some of you may already know this very well. So the idea is when you look at your GC screen, right, this is obviously what we call infinite number of answers, okay? Infinite number of answers means it's a line, so which is very clearly being shown by this, because x3 equal x3 means there's a free variable, right? It can be any number you want. So in short, that's your x, y, z. So your x, y, z can be written as 55 plus, in fact this is how we do lah. Don't waste time on things, just this, 18 minus 7, 0. Your z, not 0, sorry, 1. Your z is actually your mu, okay, because z can be any number or mu can be any number, okay, so z is actually mu. So if you stack them up, this is how it looks like, and then you just split them into two portions. Okay, so this is your R equals to this. Alright, this is the way that your teacher throw marks at your face. So if you don't grab, something is wrong. Okay, this. How many marks is this? 1 mark each, yeah. Okay, so rightly so. Nothing spectacular, nothing exciting to talk about. Okay, so let's move on. Unless, of course, you have other issue like Miss Tang. Every time I see my GC, I don't know what it means. Now that's a separate issue. Please find me separately. Okay, otherwise the whole lesson we're just going to talk about one question. Okay, because at the end we're teaching like from scratch. This is revising, not reteaching. Okay. Anyway, next one. Find the vector equation of the plane, which is the image of pi 2 when pi 2 is vector in pi 1. Aha, this is the more fun one. Okay. So this is the part that we probably want to spend a bit more time talking about. Let's have a visual of what's going on. Alright, so we have a pi 1 pi 1. Let me copy the correct one and help me check, okay? Because in case I copy the wrong one, we'll be going wild goose chase, okay? And it's not gonna. Okay, here we go. A bit more spacious. All right, so that's my pi 1, and there's a pi 2. We already know that they're not parallel, so therefore your pi 2 looks a bit like this. It's in blue. Pi 2 will be 133 minus 8. So this is my pi 1, pi 2. Now, we talk about point being reflected over to the other side, right? A flip over become B, right? Now we're going to flip the whole plane, which is the blue plane is going to be so-called reflected along the black plane, and then we're going to get another plane. And my job is to find the equation of the other plane. Cool? All right, find the vector equation of the plane, which is the image of pi 2 when pi 2 is being reflected in pi 1. So let's try to have a visual effect. So we look at things a little bit more clearly. So this is the, let's call this pi 3, shall we? That is what you want to find. The whole question is very long. It's got many parts, and it's all linked. Okay? But let's go through the basic concept of finding the equation of plane. What do you need to find equation of plane? That's important, right? All right, you need 1 point, 2 directions. That's a basic ingredient, right? 1 point with 2 directions constructs a plane. Alternatively, you need 1 point and 1 normal. But the 2 direction gives you the normal anyway, right? So it's the same kind of requirement. All right, so if you look at the red plane, do you have any point on the red plane? Because I need 1 point, 2 directions, right? We all talk about that. So do I have any point on the red plane? Answer to that must be a yes. Why? Because you just found the intersection intersection line. So you know what this line actually means, right? This is the intersection between the blue and the black, okay? Which is the pi 1, pi 2. In other words, this is the equation of this line, this blue line. All right, so this is the equation of that line, which is the intersection between the blue and the black plane, pi 1, pi 2. Now, if the blue line is on pi 1 and pi 2, it must be also on pi 3. Make sense? So, meaning to say, if you take a look at the red pi, or if you like, the red plane, you already know that there's a line on it. And with the line comes with a point and a direction. So you really already have 1 point, 1 direction on the red plane. Understand? You just need to understand that. Okay? So the red plane is not as mysterious as you think. You know, like, oh, I know nothing about it. That's not true. Because if I were to just draw it out separately, okay, this is how the red plane look like, which is pi 3. You already know on the red plane there is a line, and the equation of the line is this. And therefore, comes with the equation of the line is a point, the information of the point, and the information of the direction. But that's not good enough, right? Because you need 1 point, 2 directions. I have 1 point, 1 direction. Well, we need one more. One more what? Direction. But what makes a direction? 2 points. 2 points connected together give you a direction. So in short, you don't really need another direction, but what you really need is another point on this red plane. The other point, right, let's imagine you really have this point on, then you can form another direction. Then you have your condition all met. Understand? So you must be always very clear about what exactly are the things you're looking for. Otherwise you'll be like going wild goose chase, don't know which goose you're chasing. Clear? I need really just one more point on pi 3. That is what you're supposed to be doing most of the time here. Okay, so now think. Looking at the picture, is there any point that you know that is not on this line? No, right? To be honest, nothing. Meaning, ask yourself this question. Do you know a point here? Or elsewhere? That's where you hunt for inspiration, because all this part 2, part 3, part 4, all these are, well, talking about the same thing. So, we actually have, because that's called point B. Now notice that what B is. Actually from the start, they told me that A lies on pi 2. Okay, so maybe now is the time that we put in all the information into this grand picture here. A lies on pi 2. You know how A looks like? Pi 2 is the blue one. So A is here. All right, on pi 2, right? Okay. What we did in part 2, if you haven't noticed, part 2 talks about the reflection point of A along the black plane, which is the mirror, which was what we did here, right? This is a lot of work, but we did that. So the idea is your point A lies on the blue plane, and the point A is being reflected, and guess what? Where you land? You land here, right? And this is the point B. And we found it. I can't remember the answer, so I need to find. It's all the way here. -3, -1, 6. Okay, so that's the -3, -1, 6. Super long question. -3, -1, 6. So that is the point B. Now this point B is something that you know lies on pi 3. So I do have another point. Now with 2 points on pi 3, you can find your second direction. And you're done. 3 marks. Not a lot of work, but a lot of thinking and fusing things up. All the information must be clear. Understand? So what you want to do is this, okay? You want to say that, oh, you know what? Direction on pi 3. Of course, you have to name it pi 3 yourself, right? Let the plane that is reflected be pi 3. Otherwise, nobody knows what is your pi 3. Okay, so will be equal to this point B minus the given point from the GC, right? Which is, now this is really hard, minus 58, 21, minus 20, and then 6. I hope we're getting this right, okay. Anyway, so that's my direction. Cool? And direction can reduce, and you should reduce. All divisible by 2 only, right? Okay, so actually no fun reducing, so never mind. Reduce, you got 26, minus 10, 3. Okay, so reduce it to a nice looking direction. So there you go, guys. This is your direction of the red plane, the second direction on the red plane, and the point on the red plane. In fact, when you talk about point, you do have choices because you have 2 points now, more than what you require. Alright, so choose one point that you like. I obviously prefer the smaller number rather than big number. So you can now say that my pi 3 looks like this. Now lambda, mu all used already, so use other things, okay? Usually we use S. And then T. Where S and T are real numbers. Now your answer may look different, and that's okay. Because some people may have a different direction in the sense that the signs are all opposite of mine. But that's okay, right? Opposite sign is fine. Some people may use a different point rather than use this point. They use the other point, which is 55, 21, 0. And that's also fine. Okay, cool. Any questions? Quick. Takes a bit too long, but that's because, yep, we do have other things to talk about. Okay, so all right, it's just seriously too long for one question. Let's move along. Of course, if you have a question, please ask. Okay, so the whole idea of revision is this: that you don't understand anything, you can ask. Okay, so let's take a look at question 2. All right, ready? I'm not too sure whether I got enough space for this, but yep, all these are very massive questions. So in exams, this is what you have to get used to. Okay, and therefore it's quite a lot of marks as well. Okay, so let's talk about this. Refer to origin. I have point A, which is this. Now, I don't like IJK. I don't know about you. Okay, so the truth is for me, things looks much easier in column vector form. Okay, and this is what I will do first. All right, so OA, OB, OC, all I write down first, and I have all this. Find the equation of the plane pi. Now, what is pi? The line L has a vector equation like this, so that's the line L. Now, this line L looks a bit strange, because we all understand that for the equation of a line, we have two main components, which is a point plus a direction. Agree? So, this one seems to have only the direction component but no point. What this tells you is one thing. The point is origin. Okay? So origin lies on this line. Alright? Because otherwise it will look a bit like this. Which nobody will write, right? So that's why when you see something like that, you need to understand, oh, origin lies on the line. Okay, cool. So I have a line, I have 3 points. A plane called pi contains the line and the point called A. So if you try to visualize, this is how it looks like. I have a plane. On it, there's a line called L, right? You want to call this L, up to you. On the L, there's a point called origin. And on this plane, there's a point called A. Your job is to find the equation of this. And you need it in this form, which is the normal form. So r dot n equals a dot n, so the p is a constant that you have to find. So you need to first of all find the normal. How do we find the normal? We cross 2 directions together. Correct? So the first direction is of course the direction of the line. The second direction will be the direction of OA. Get the idea? Alright, so the direction of OA is just OA. The direction of the line is 1, 4, minus 3. So the normal is actually 1, 0, 0 cross 1, 4, minus 3. That's the normal. And when you do a cross, you should feel quite happy when you see zeros around, because it's like, hey, that's nice, easy to cross. So let's cover the first row, we get 0, right? Cover the second row, we get minus 3, but then it turned out to be 3. Cover the last row, we get 4. Okay, so that's pretty nice. That's my normal. Once you get a normal, then you can find this pretty fast, because you got n already, right? So all you need is the p, and of course you probably want to memorize the formula called r dot n equals a dot n. It's not really a formula, because it does nothing but help you find the equation of the plane, that's all. It's like y equals mx plus c. It's not a formula. It's a form, right? It's a form that helps you. So this is r dot n equals a dot n. So the p is literally the a dot n. Now what is a dot n? A dot n is take a point on the plane dot the normal. Well, if the origin is on the plane, then you should use origin, right? Then you don't even need to do a dot. Okay? Origin lies on the plane, you'll always be 0. I mean, you can use the point A to go and dot, you get 0 also. You can use any other point to go and dot, you get 0 also. But the whole idea is that if you know origins on the plane, confirm you get 0. Okay? Literally, this 2 marks is just to do the cross and the understanding of things. Okay? So that's it. That's done. Go to the next one. Find the cosine of the acute angle between the line OA and L. Now, this is not that difficult, because there's only one formula that allows you to find angle between 2 vectors, and that's called the dot product, right? So it's pretty obvious what we want to do. So we have, actually the diagram is right here, right? It's OA and L, which is this angle. Okay? But they're not interested in the angle, guys. They're interested in the, what is that called? The cosine of the angle. So they want the cosine theta kind of view. So this is not that hard. So if I can take OA, dot the direction of the line, which is 1, 4, 3, is equal to 1, and square root, what is this? 4, 3, 26. Correct? 26. And then cosine theta. Alright, now they want acute angle, which means this better be positive. So if not positive, you better mod it. Okay? Otherwise you get obtuse angle, right? Remember, cosine negative means the second quadrant, so you'll be obtuse. So, but anyway, from the look of it, is positive, so we are fine. So cosine theta is, by the way, this is 1. 1 over root 26. And we are done. Ta-da! That's the, find the cosine theta part. Hence or otherwise, find the perpendicular distance from A to L. Now, this diagram is a bit too tiny now. Maybe we should draw it out a little bit more enlarged, so you can see things a little bit more clearly. So here goes space. All right, let's try. So this is the line L that is on the plane. On the line L, there's a point called O, and somehow there's a point called A. And what I found is the cosine of this angle called theta. And now I'm trying to figure this out. Now the truth is, finding this distance is not something awfully difficult. You can use the A cross B cap thing, right? Yeah, and you get it. But if you want to use hands, how? Okay, again, you want to keep things in the perspective, all right, that you can do it. All right, you can do it because you know what is OA, which is the hypotenuse side. You know what is the L's direction, which is this one. So this length is the opposite length, is the sine version, so it's the cross version. So you just take this cross end cap, and then you mod it, you get the answer already. It's actually quite simple, all right? But what if you want to use hands? Can I use this answer as a help, as the guide to help me get there? Not impossible, but well, it's a matter of whether you want to do it. Okay, let me just show you that one in case that's what you are thinking. Let the length be x. I think it's easier for me to describe my point. Okay, so how do we find x? Well, it turns out that if you want to rely on this, then you understand that your cosine theta is 1 over root 26, which then tells you that the ratio is 1:root 26. Agree? Now, I mean, come on, cosine, right? Adjacent over hypotenuse. So, therefore, by Pythagoras' theorem, you somehow figure out that this is 5. Hold it, not so soon. It's very tempting to think that that is your length. Very tempting, but it's not true. Why? Because all these are ratios. Ratios are not actual length. Agree? So if I tell you the ratio is 1:2, it doesn't mean the length must be 1 and 2. The length may be 10 cm and 20 cm. Get the point, right? Cool. But that obviously helps, right? Because if you know the ratio, and guess what? You actually know the length of A. Because the length of A is 1. I mean, right? The hypotenuse length is actually 1. Alright? So it's actually not hard, because that's why it's a hands part, right? You can just do it. But if you think about it, right? So the okay, let me just write it down for you. Okay, length versus ratio. So length is 1, is represented by, or you want to call it unit, okay? Root 26 unit is 1. Okay? So 5 unit is what length? That's all. 5 over root 26. So that's the length. It's a bit like primary school already. You know what I mean? This rate and proportion. The number of units represent length 1 cm. Then now the number of units is 5. How many cm is that? That's all. Convert it. This is what they meant by hands. And therefore you do it in a very neat way, right? No working involved. Not much working involved. You really just borrow the answer. Can? Of course, the longer way, the otherwise will be the cross product that I described to you. So OA cross this cap, mod it, you get the length. It's the same. You're going to get the same answer. You can try. Alright, but I don't know what you did, but the idea is you can try. Okay, but this is the hands part, which I believe is more useful to talk about rather than to talk about the cross one. Alright, last one. Sorry, not last one, second last. Find the shortest distance from B to plane pi. What the heck? Where's B? I forgot that there's a point B, right? So it's, yeah, there you go. 1, 1, 1, thank goodness, it's quite easy to remember. So I have a plane called pi, which is right here. Now it's very messy because there's like so many things going on. So again, let me try to find some space. Instead of doing this scrolling up and down, it's really giving me a headache. Like I always like to say, you try to keep things into perspective. There's a lot of things going on. So a lot of times you don't have to deal with all the things simultaneously. And in this part 3, you're only dealing with 2 things. Point B and plane. So you really probably just draw out. This is my plane. This is my point B. And this point B is called 1, 1, 1. The point plane pi, I found in part 1. So maybe I borrow the answer here. Alright, which is here, right? R dot 034 equal to 0. So you want to minimize your problem. Your problem is really just this. These 2 players here. And what you are interested in? This length. That's it. How to find this length? Well, we have a few ways. In fact, 2 main ways. One is to find the full perpendicular and then mod this. Not hard. Doable. but a bit long. So you're going to skip that, okay? So there's a shortcut, or I won't say shortcut, but there's another way. And that is to figure out a point on this plane. Let's call this P. And once you got the point that's on this plane, you can join them up, and you got the BP or PB or whatever. All right, and once you got this, you got the hypotenuse side, and therefore you can find, well, the opposite length using the cross product. No, in this case, dot product. Okay, dot product because the angle is here. Okay, cool. So this is, I think, what I would like to do. All right, and guess what? The point P is not even difficult because you don't really need to find because, well, we can use O, right? I think O is so much easier. Okay, O is a point on the plane. Well, what for you go and use other point, right? It's so nice. You just use O. Okay, so O, B is just 1, 1, 1. So the shortest distance, or if you like, the required distance, is really just OB dot n cap. OB casting a shadow onto the normal. That's it. It's dot, not cross. Okay? Again, you have to learn how to identify it quick and accurate. Alright? Why is it dot? Oh, well, because the angle is here. Well, then this is the adjacent side, not the opposite side. Okay? So you are very clear-minded like that, then all these are super easy because the information is there. If it's not there, sometimes you got to find it yourself, but that's it. Okay? So n cap is that one. Well, we're going to have 7 over 5. 3 marks. Okay? If you know how to do the 3 marks, is not scary. I mean, come on, the steps are not scary. Questions? No questions? Yep. How do I know is this angle and not this angle, right? Okay, always ask yourself this question. Now, the vector you have is always the hypotenuse side. Then there's always one more vector that you have. Because if you, out of the 3 sides, you only have 1, you can't do anything anyway, right? So you always have one that's the hypotenuse and one that is somewhere else. The angle will be the angle formed by these two. Okay? So hypotenuse you have. What is the other vector you have? Well, that's the normal one. The normal is a 0, 3, 4. So it can't be this because I really don't have this vector or this direction. Anyway, so the 3 sides in the triangle, you always have 2. All right, one of it is the hypotenuse. Then the other one will be, well, the other one. Okay, clearer. All right, that's it. All right, so it's not that scary, but this is mighty important, like I said. You see, almost every question we do this. A dot n cap, A cross B cap thing. It happens all the time, okay? And in fact, these questions are not the hardest around, really. Let me just tell you first, okay? But I think for revision's sake, this is useful because it brings about all the things you need to learn, all the things you need to know. But besides knowing this, you need to know how to handle harder questions. Okay, harder questions are not a lot harder, it's just a lot more messy in their information, that's all. Alright, so once you clear up the clutter in the information, what you are doing end up with the same. Some, like what laser beam shoot here, then reflect there. End up, they are doing the same thing also. Okay, it's just the story that they give. Okay, anyway, shall we move on? This is probably the fun part. I like to, fun part because unusual. Okay, unusual, and every question in the exam there will be some unusual parts, and you have to think on your feet. That one I can't help you. Okay, so that's something you cannot prepare, but this is what you can prepare. The skill sets that you need. Find the value of m for which a plane pi, okay, cuts the line BC internally in the ratio of 1:m. What? Okay, sounds weird, right? Okay, seriously, I have no idea what I'm talking about. But anyway, based on my diagram that I have, you know what? I'm going to redraw this diagram one more time. Okay. Do I need to? Okay, maybe I need to. Let's try. So this is the plane pi. And on the plane pi, I actually have this point called B, right? So C. Have I missed out something on C? Oh, it seems like I do have the point C, right? Just now, yeah? I wrote it down, but I haven't used it. Okay, so there's a point called C somewhere. But you probably guess that the somewhere may be here. That's the point C. Okay? So the plane cuts BC in the ratio 1:m. 1 is to m. Find m. Okay? First of all, think of a way to do this. Then we talk about the questions that comes with it. Okay? Well, there should be questions, I hope. One of the questions is, I think it's useful to ask, must it be vertical? Did they say it's like that? We don't know exactly. But I draw it like that because it's easier to see. And then easier for us to talk about a strategy to solve it. Okay? And it turns out that regardless whether it's vertical or slanted, doesn't matter because the strategy will work. So let's think of the strategy first. Okay? So now we are looking for this m. Well, what do you think you need to do? How do you think you do this? Well, let's assume that it is straight like that first. Okay? I think that helps us a lot. That will be pretty useful. Okay? But we'll talk about the other way later. What if it's not slanted, then how? Okay, but it turns out the idea quite simple. I have point B. Wait, I forgot. I should have written it down. Point B is 1, 1, 1. Point C. Again, the idea is you try this at home, right? And I don't know how many of you actually managed to solve this. Anyone solve this? What's the answer? 3, right? Yeah. Anyone solve this? How do you do it? Share with us. But then you're assuming it's the perpendicular one. Oh, you find the intersection. Okay, that's a good strategy. It will work. Okay, what Yang Ying did was this. He go and find the line BC, and then he go and find this point called F. And then once you got the point F, you can find the BF vector. You can find the FC vector. You can find the distance. You mod them, you get the ratio. That's a lot of work. Okay? Now, but that strategy is very good. You know why? Because if it's perpendicular or slanted, it still works. Because the line BC slanted doesn't matter why. You still find the intersection point, the ratio is still like that. Okay? So you understand his method? I like it because it works, no matter slant or not slant, but it's a bit brute force. Not so elegant, right? Yeah, but it works lah. Not so elegant, it works. What is the more elegant way? Well, you probably want to use this. You remember that we actually found this distance? 7/5. Okay, now the other way that you can do this is, pay attention. Precisely the same kind of idea right here, but you are going to use, this is point C, right? Okay, you're going to use the point O, C, and cast a shadow onto the normal. Then you can find this M already, or rather you can find this length. Okay, so it's the same kind of steps like part 3, but you are using C instead. So you can actually find, okay, the distance from C to pi. Okay, so from C to pi, and then you have 6. Okay, it's actually OC dot n cap. Okay, if you ask me, it's the mirror image of part 3. So it's, instead of finding this length, we're finding the length below, but it's still OC. Okay, so OC dot n cap. So OC is 6 minus 3 minus 3. Dot n cap is the same. 1/5 this. Okay, so we're going to get the length of 6/6, sorry, not 6. It's going to be minus 9 minus 12. So that's minus 21. So it's going to be 21/5. Okay, so what we figure out by this purple color part is that this length is 21/5. This length is 7/5. So m is to 1 is 21/5 over 7/5. Okay, so m is 3. This kind of question, not uncommon in exam. Okay, because they actually give you a diagram and they actually give you the IJK thing. Alright, so you just have to sometimes know how to count properly, but I think this question, if I'm not wrong, if I don't remember wrongly, you don't need the diagram so extensively. Okay, Anyway, let's talk about this quickly. We have 3 points that we know called EFG, which is on the roof, right? So EFG looks like this. Again, I don't quite like the way that it's presented. I like the column vector way. So EFG forms a plane, and the plane is this, and you're supposed to find this equation. That's all. So in short, the problem can be simplified into thinking like I have 3 points. I need to find the equation of the plane. That's it. So you need to then understand what you need to find the equation of plane. You need 1.2 directions, and now you actually have 3 points, enough for you to find the 2 directions. So let's write it down first. OE is 0, 0, 6. Okay, so there you go. That's the EFG thing, right? So you need 2 directions. So let's get the 2 directions. It's a bit troublesome, but only 2 marks. That's quite painful. Okay, so we go get EF, which is 804. All right, so that's EF vector. Now, actually, now that you look at it, you probably want to change it to direction EF. All right, and why? Because I'm going to use the direction to do crossing, right? So we do crossing, the smaller number, the better. So direction EF, because it's a direction you can reduce. So you should reduce. Rather than deal with big numbers, and then you do the cross with the big numbers, you have higher chance to make mistake, okay? Next is, let's see, EF or EG or GF. Which one is easier? As long as you got a 0, that's usually easier, but I don't think you have. All right, so it doesn't matter. Okay, doesn't matter which one you choose. Let's use EG then. Okay, so EG, direction of EG is OG minus OF again. And again, you can reduce 1, 2, minus 1. All right, I do want to emphasize a bit because presentation is very important. If you, like me, present it as direction EF, then you can reduce because direction EF is indeed this and therefore this. If you present it like EF vector, and then you say EF vector is equal to this and this and then this will be wrong. Concept is wrong. Vector cannot reduce. Okay, vector is formed by 2 fixed points and therefore it has a fixed length. So vector is not direction, direction is not vector. You mustn't get confused by these two. So notation is very important, okay? So if you write as EF vector, then I'm afraid you cannot reduce. But if you label as direction vector of EF, then fine. That's totally fine. Okay, so once we got to here, why do we even do this at the first place? So we have to find normal, right? Okay, so we find normal. This one, be careful, don't waste marks here. So cover the first row, I got 0, 0, minus 2. Cover the second row, I got minus 2, minus 1, so that's minus 3. Turns out to be 3. Last one is 4. Alright, so that's my direction of normal. Normal is a direction, and therefore I can reduce, but in this case cannot, so we leave it alone. So I got direction already. I got normal already, and I want Cartesian form, right? So I just need to choose a point. So the formula goes r dot n equal a dot n. So r dot equals to any point will do. Of course, you choose the easiest one. 24. So you're going to have minus 2x plus 3y plus 4z equals to 24. Okay. 3 minus, yeah, I think it's correct. Okay, looks correct to me. Okay, I think that's all right. Questions? Should not have. Let's move along quickly. Chop chop. Should be easy. Okay, obviously you'll find this easy because this is like basic stuff. All right, second part. Find the acute angle between the plane EGF, which is the roof, and the horizontal ground. So in short, they are really testing on one thing, and that's called how to find the equation, the angle between 2 planes. And you need to understand that to find the angle between the 2 planes is the angle between the 2 normals. Are we all good? Okay, so if you look at a full set of notes, angle between 2 normal and the angle between 2 planes are the same. I think there's a picture in the notes that draw quite nicely for you to see. So I shall not explain any further, but just do it. Okay, so angle of normal of the plane or the roof, if you like, what we just found. Now, we need the normal of the ground, okay, which is OBA, right? That's the ground. So what do you think the normal is? Pretty obvious, huh? Okay? So the normal of the ground, it being the ground, means it must be flat. So it's 0K. Alright? So as in, the normal must be K, is that right? So I and J can be anything, but K cannot have any height. So the normal must be 0, 0, 1. Okay? And this is how the diagram comes in useful. Okay? Because the ground is the plane, and therefore the normal is the one sticking upwards, which is K. So that's the normal of the ground. So the angle between the two planes is the angle between two normals. So you go back to day 1. Did they say a cube? Yeah, they say a cube. So make sure it's positive. I think it is positive. All right, this one is 25 plus 4, that's 29, right? Okay, so cosine theta is 4 over root 29. And they want the acute angle, so we do get the acute angle because it's positive. So we should get the answer. I think I'm in different mode, so let's change degree mode. Okay, so cosine inverse 4 divided by root 29, and I think we are done. 42. Good. Is that the answer? Let me check because I obviously cannot remember all the answers, right? So I'm just okay. Good. 42.0 degrees. Okay, that sounds good. Let's move along. Part 3 now. The engineer has to drill a hole on the roof. Okay, whatever. And in order to install a lamp, given that the lamp is vertically above a point on the ground with a position vector of this, find the vertical distance from the drill hole to the ground. Now, this is how they make it sound confusing for you, alright? But the truth is, you want to learn to simplify your problem, okay? So the problem is this, okay, you know what? I have the ground. This is my ground. On the ground, there is a point. The point is called 320. Okay, so let's jot down the point here. Shall we call it P? Much easier, right? 320. Now what happened at this point? Well, is that vertically upwards, there's a lamp. Now this lamp is not dangling nowhere, right? According to the question, it says that the lamp is on the roof. Okay? So this lamp is actually on the EGF plane that we found, right? Which is here. What we want is to find the perpendicular distance, which is, well, this distance. Okay? 2 marks. How do you do this effectively? Okay? How do you do this? 320, which means, sorry. There are a number of ways to do this. Again, the vectors is one of the reasons why it can be confusing for some people is because sometimes you do it this way, sometimes you do it another way. Alright, but because, let me just tell you one way first, okay? But I don't think I want to do it that way. But I think we can try. And that is this. First of all, this ground is a plane that we know. We know very well. In fact, we know the equation already. The equation is r dot 001 equals 0. Because the normal is 001 and it contains the origin. Correct? If you look at the diagram, the origin is on the ground, right? Okay, so there's nothing too spectacular there, right? So that's the ground. Now, if you think about it, therefore you know the direction of this LP. And if you know P, you can find the equation of the line LP. Am I right? And if you can find the equation of the line, you can intersect with the roof. And therefore you can find the point L by doing simultaneous equation. Once you found the point L, you can find the length, which is the mod of LP. Agree? For 2 marks, not fun. Not worth it, but it will work. Anyone actually solve for that and using this way? Nobody. Okay, so good, because that is something that will work, but a bit too long for 2 marks, right? So you try to hack it. Okay, so let's think about the hack. How are we going to hack it? That requires a bit of looking at the diagram. Okay, the diagram does help at times. Okay, so understand this. Where is this point? 3i, 2j. Well, literally means it's 3 units here, 2 units there. This is where the point P is. Okay? Or on top of it, on the roof. The lamp must be on the roof, right? So on the roof means it's vertically up. When you are going vertically up, the only thing that changes is the k coordinate. Okay? Make sense? Because when you're at the position and you're just going upwards, that position I and j is fixed. But the k is the one that makes you go up. So the point L that we are talking about here, like, on the roof, right, is vertically up. So we actually know something about L, despite we don't know it exactly, but we know that it must be 3, 2, well, something. Make sense or not? It must be 3, 2, something, right? Because, it's vertically above. The only thing I don't know is the something, right? Make sense? Now, and that something is not impossible to find, because you know that this point L, after all, lies on the plane EGF. And in order to lie on the plane EGF, it must be able to fit into the equation EGF. In short, to find L, okay, don't even need this. You just have to put in x equals to 3, y equals to 2, and then you get your, hold on, you found your z. Z is the k, by the way. Okay, so in case you didn't know, I don't think you didn't know that. Okay, so what is this? Let's try. This is difficult. 24 minus 6 and then plus 6. Why do I need a calculator for this? Sorry. Alright, so it's 6. Am I right to say that? So the L is 3, 2, 6. So what's the height? 6. K measures the height what? From ground up. So the height is 6. That's why it's 2 marks. Understand? Okay, it's a very obscure kind. It's like, wow, abstract to some extent, because you see the working is like so simple. Secondary school kid can do this, right? But it's the meaning behind what you're doing that is what you want to learn or what you want to get used to. Okay, now this is not anywhere in the notes, because this is a particular question for a particular kind of situation. Alright, you just have to try to problem solve on the spot. There's no particular formula to solve this, but you get what I mean? But like I say, worst come to worst, you can actually solve it using all the hardcore way that you learn. Yes, you want to ask something? Oh no, okay. Alright, but you get the point? Can? Important because it's 2 marks, we want to do it like 2 marks. But of course, if you do it a long way, you still get the 2 marks, obviously. Okay, wow, that's not the end of it. Okay, come, let's run through this quickly. Same question. Now I have a point called M, and the point M lies on this EF, which is right there, and then the engineer decided to construct a vertical wall, which is the shaded part, right? Given that the partition wall is they give us the equation, which is awesome. I don't know why, but find the equation of the line GM. Okay, now this is actually quite lame. 2 marks, and I would say rightly so, because the line GM, if you haven't noticed, is actually the intersection between the wall and the roof. Okay, now they look at it, pretty obvious. And the roof, we have the equation here, part 1. No, sorry, it was shown, right? Yeah, there. Minus 2x plus 3y, this is a roof, right? So minus 3x, minus 2, 3, 4, 24. Minus 2, 3, 4, 24. So this is the roof, and that's the wall. Simultaneously solve it, that's all. Okay? So it may sound like very funky, like wall and all this. It turns out actually it's really just doing the same thing again and again. Alright? They camouflage it really. But you like I say, you do want to be able to identify and figure out the camouflage so that you can actually sort things out quickly. Okay, I think we are quite done with this. Okay, stop. Okay, cool. Again, it's about reading this, so because it can be quite difficult to read. So let me try to just screenshot here, so it's much easier for us to talk about it. So if you are fast enough, then of course you can do this straight away. That means you are quite seasoned with it. But if not, then you just do slow-mo lah. It's fine. All right. So this is 0, half, and then 8 minus 1, and then 0, 1. But nobody likes to do fraction like that. So you may want to simplify this by factorizing out the half. So you actually get factorizing out the half. So you actually get 1, and then minus 2, and then 2. Okay, because after all, it's a direction. I mean, no harm leaving the half inside. It's fine. I think the answer says that. Okay, but of course, you try to beautify it a little bit. Lambda is used in the question or not? I can't really tell because I've been split over so many pages. But if lambda is used in the question, don't use lambda. Okay, use mu, use gamma, use alpha, use s, use t, whatever you want. Okay. So, but the whole idea is to please tell people it's a real number. Okay, so this is easy. Let's move on. Find the shortest distance from A to the vertical wall. Okay, now that sounds a bit interesting because you know what they want? They legit want something like this length. Okay, which is if you think about it, alright, it's actually not hard a problem. The problem is this: I have my wall, except now. Okay, I probably don't draw my wall like that. Okay, so I have my wall, and I have a point called A, and I want to find the shortest distance. That's it. I mean, we've been doing this a lot of time, right? You can use the projection thing or whatnot, right? The kind of idea. Okay. Question. How to do? I got the equation on the wall, Mr. Ang. That should be useful. Yeah, I do agree. So the equation on the wall, let's call it W. W for wall, of course. R210 equals to 8. So this is the what's that called? Equation of the wall. In order to find this distance, like I said, you have a couple of ways. We talk about the couple of ways many times today, okay? But one way that I like a lot is this. Just find one point here, shoot this over, right? And do a dot product against the normal. So this is this dot n cap, you get the length. 3 marks. Not that hard. Finding this point is not a challenging thing because you got the equation. It's just simply you can call it 400. As long as you put inside you get 8, you're fine, right? Okay. Yep. So 400 is this point. Okay, never mind. 400 is this point on the plane. The really thing that is missing, the real thing that's missing is the point A. Because as of now, we don't have point A. Understand? Okay? But the strategy is already, you get me now, the things that you can prepare for your exam. This is the thing that you can prepare for exam because you need to prepare like the skill sets. Oh, if I want to find this, I can. I don't do this, I can. So now this is the skill set. You ask yourself, okay, I want to find this length. I have got the equation plane. I just have to do this. All right? You have the skill set. But do you have the information, right? So now we just realized one thing. Shucks. I don't have the point A. Or do you not have the point A? That's an interesting question. Come on. By the way, how many of you actually solved this? What's the answer? Let me check. Not a very nice number. Okay, but whatever. Answer not very important also, right? So, what is this point A? Do I have my point A ready? No, I don't have it ready. Anyway, so we need to look at the diagram to help us figure out things. Okay? So, we need the point A to find the distance. The point A turns out to be, let me see. Okay, this is how we find point A. No wonder, because it's not on this page. We need our F. Do you know what's F? Yeah. 8, 10, 0, no, sorry. 8, 0, 10. Okay, so this is how me remember 8, 0, 10, right? I think I wrote it here, right? 8, 0, 10. Okay, so let's just write it out there. OF. First of all, you know something about point A or not? You should. You should know that despite me not knowing much, I know that point A has got 0 height. Okay? But I really don't know what are the rest. So how do you know what is the rest? Well, that depends on your F, because F is vertically above. So then you realize that F says that you have to move 8 units this way, and 0 unit of J. Agree or not? Then you move up by 10. So literally this is 10, this is 8, right? 8, 0, J, but 10. So if you can do this kind of counting, then you realize that to get to A, it's just 8, 0, 0. Because A is vertically below F. And like I said before, if it's vertically below F, the first two coordinates must be the same, right? Only the height is different. So that's how you figure out A. A turns out to be 8, 0, 0. So if you know that A is 8, 0, 0, okay? And then of course you can start to do your shortest distance thing, right? Because you can find the point A and all these things. So let's try to get it done. Okay, so the what is this point called? Should I call it P or Q? Maybe P was used earlier on, I can't remember, right? So a point on the plane, and the point called A, that's 8, 0, 0. And I'm going to try to find the shortest distance, which is the QA dot n cap. Okay, so let's try to get the answer. So first of all, I need to get my QA. So QA is 8, 0, 0. Minus 4, 0, 0. So this is a very simple calculation. So that's my QA. So QA dot n cap mod. So that's going to be 4, 0, 0. This thing, right? This thing mod. So it's 1 over square root 5, 2, 1, 0 mod. I don't think you get negative anyway, so that's fine. So we're going to end up with 8 over root 5. Sorry, a bit crowded here. 8 divided by root 5. 3.58. Yeah. 3SF. Is that a correct answer? Yep, that's it. That's quite a lot to talk about today. Are we all clear? Can? Alright, so this question is particularly a little bit more interesting. Okay? Super long question. Right? Not that fun. Okay, come. Last one. To be honest, I read this question as I was putting these slides on and all. Then I realized this is a bit too easy, you know. So I'm actually not very keen to go through this because it's so easy. But then, we were talking about revision, right? So how many of you actually really tried doing this? Okay, get all the answers? All correct? So the rest never try or cannot get all, never try lah. Haven't tried, okay. So I think it's easy because like I said, you see, we've done all this. I mean, everything that needs to be done here, we discussed today. Okay? So the truth is, I find this a bit repetitive. Okay, so in order to make the best use of our time here, right, I do have another question that I saw, and I think may be more helpful for us to talk about, and that is on page, hold on, let me find. This one. Page 4, which of course you didn't practice this, or rather you didn't prepare this because I didn't ask you to. Page 4, question 2. Now, this is the kind of question that I usually get a little bit more concerned with because no numbers, right? I think you should know that there are two types of vectors question. One type is those that we just do a lot of rah thing, you know, like, oh, find the normal, find the point, find the projection, blah, blah, blah. Those that we just done, you know, like very busy question. These are those with numbers. So words come to words, you can just do some adding, dotting, crossing, you know, you get some marks. Then there's another kind of question, whereby the numbers are very, very minimum, like this. But this is not the worst lah. There are worse ones, and of course today we also didn't have a chance to talk about locus. You remember what locus is? Right? Locus is not the grasshopper, but I mean the path thingy and stuff like that. So I think that in order to spend our next 10 minutes or so, we don't really have that much time. I feel that it's probably more bang for the buck if we go through this one rather than the question 4. I know I asked you to do 1, 2, 3, 4, right? But 4 I find okay. You should be able to do. In fact, why not you do it as a test yourself later on, right? Go home, try to do the question. You should be able to get all correct. Quite easy, okay? This one is the one that I think we should spend the time on. So shall we read through together? Because I know you haven't prepared this, but it's fine. Let's read through and we do together, okay? Do together, we discuss together, and then we face the problem together, and then see whether we can solve the problem together, okay? Oh yeah, Xingyi, you don't have this paper, huh? You have? You didn't bring? Oh, okay. So you have, huh? I'm just concerned that you don't. Because if you don't, then they'll be quite dysfunctional, right? Okay, I think you read through, but the important thing is you know what to do or not. Or what did you have to do? Let's have some discussion and let's have some broad stroke. All right, I think the broad stroke is important, like what exactly you are trying to do at the first place. Shall we? Come, let's talk about this. I think this is definitely more worth our time than to go through something simple. Okay, let's see. With reference to a point O, 2 points A and B have a position vector A and B. You know what it means? OA is A, OB is B, that's all, okay? Now, OAB are not collinear, fair enough, all right? Point P divides this in the ratio of this. Okay, A is a unit vector. Mod B is equal to this. Well, this is a bit too much information, right? Like, oh, seriously. And you must know, and you must have the expectation that they don't tell you things unless you need it. So to some extent, you probably guess that you need all this information, and that's true. Let me tell you, it's true. The foot of perpendicular from P to the line passing through O and A is F. Show that this is this. Now, what the? Okay, so it's very confusing. I don't know, are you confused already or not, right? So some of you actually started drawing some pictures. Awesome, because that's what I'm going to do next, okay? So I think you should too. Let's start with a point called A. Let's go with the point AB, and AP is 3. So this is 3, this is P, this is 2. All right. I do have an O somewhere, which I don't know where, but who cares? Just label one point called O, and that's it. This is my OA, this is my OB. I think, all the things that they just described to me, I summarize in a diagram like this. Okay. So I think we are quite cool. A is a unit vector, okay, whatever. This is 4 unit, okay, whatever. The angle is called pi over 3. I don't think I want to, okay, never mind. I'm just going to label that I know it, okay? Point P to the line passing through OA, which is this line. I should have made it a little bit more slanted, but anyway. Let's imagine this 90 degree, okay? I know it doesn't look like it, but anyway. Just imagine, okay? So this is the point F. Not hard to understand, right? Now, and they ask you to show that OF is equal to this, like, come on, lame, right? Why is it lame? Because OFA are collinear, and therefore, obviously, we know that OF must be equal to something of OA, right? Because, come on, they're collinear. So, therefore, they are this. So, the show part is pretty lame, to be honest. Okay, but anyway, that's not the main thing. All right, it's pretty lame because it's pretty obvious. The collinear means it's just a multiplier called lambda. The key thing now is trying to find lambda. How do we do this? All right, so let's see. First of all, we will need to understand that it's perpendicular, and therefore, let's have a strategy first, shall we? All right, the strategy will be this, okay? In other words, to find lambda, meaning to say you just simply want to find OF. Okay, in order to find OF means you want to find the full perpendicular. Now, normally, how do we find full perpendicular? Like this, like, come on, how do we find this point F? Well, the realization is that the point F lies on this line called L, and then you know that if somehow you can find this vector, you dot the direction of that line, you will get 0, right? And then this dot this, you get 0, and then therefore you found the lambda, and then therefore you can start to find a lot of things. So, let's start off by talking about it this way. So we understand from my diagram that my PF is perpendicular to OA. I don't think anyone can dispute this. It's like, duh. Okay? Now, and therefore, we understand that PF dot OA will be 0. This is a equation that, well, you have. And when you have equation, you can solve, or at least attempt to solve. Okay, but this equation is not quite solvable right now because it's all over the place. So we need to go and try to figure out what is PF. Because OA we know already, right? So PF, okay, let's get to work. Alright, PF, I need point F, and point F is not, point P, sorry. Point P is not difficult because point P turns out to be ratio theorem, right? So you can find your OP rather easily, and that is 3B plus 2A, spell A, over 5. Alright, so that's my OP. Alright, that's pretty cool. Alright, next thing is OF. Now OF is lambda A what? Okay, so PF is OF minus OP, which is OF is lambda A minus OP, which is okay, wait, hold on. Let me just simplify at the same time. Minus 3 over 5b. So far so good? Okay. So you may want to simplify a little bit, which is going to end up here. Lambda minus 2/5 A minus 3/5 B. This is my PF. Cool? And why do I even find PF in the first place? Well, because I wanted to try to use this dot product formula equation to help me solve things. So therefore, from here, I figure out that my PF, which is this, dot OA, which is A, is equal to 0. Now, guess what, guys? By right, I'm supposed to try to find my lambda, right? And I think I have an equation that allows me to have one unknown called lambda. And in normal times, when you look at an equation like this with only one unknown, you should feel quite happy with yourself. Like, yes, I'm getting somewhere. Okay, except that this is a vector equation with a dot product. So you better be clear about dot product. It's not algebra. So it's vector, it's not algebra. So you want to know that you can do dot product distributive law. So do it carefully. Okay, so you're going to distribute in this. Okay, you know what I mean, right? Distributive law. So we're going to have this. A dot A is mod A square, guys. And then 3/5 of B dot A is equal to 0. Now, mod A is 1 because they mentioned that A is a unit vector. Whew, that's good because we end up having nothing, right? But we have another problem, which is this B dot A. Now, this B dot A is very annoying. It's a number, but I don't know what this number is. So you need to go and try to sort out this number. And turns out there's one more piece of information that we haven't used, which is the pi over 3. Am I right? Yep. So the angle between A and B is pi over 3. What it means is that if you were to go and do the dot product, you will get this. So if you're going to do the dot product of A dot B, you're going to have mod A mod B cosine 3 over 2. Now guess what? A dot B you don't know, right? That's the whole idea, right? You don't know the A dot B. But let me highlight the things that you don't know, okay? And that's why we are even coming to here. Alright, now mod A is 1. Mod B is 4, I remember reading it. Cosine pi over 3 is cosine 60 degrees, that's half. So it turns out that you somehow figure out that A dot B is equal to 2. Ta-da! That is mighty useful. Because now that you know A dot B is equal to 2, this becomes 6 over 5. And therefore, your lambda is 8 over 5. Okay? Understand? This kind of question is very annoying, you know why? Because when you do it, you get the feeling is that you get stuck badly. But when you see people do it, it's like, hey, actually quite easy. Alright, so that's why it's scary. Alright, no number questions are always have this sense of uncertainty involved. Okay? Alright, so this is probably like the shortest question. Alright, but that's because there's only one way to do this. Okay, I don't think you can have like multiple ways like the other questions. Alright, so those bigger questions, sometimes you do have other ways. Alright, Ken? So I hope this helps you with a revision in the sense that all the necessary skill sets are discussed. Okay, but like I say, you ought to try more because there are harder questions around all the time. Okay, so these are not the hardest really. Ken? Alright, so that's all the time we have for today. I hope you learned something useful.